Hello, friends. This is Dr. Bishwapriya Chatterjee, Assistant Professor, Electrical Engineering Department, Alia University. I am introducing an academic program for undergraduate students of electrical engineering stream. This program starts with the course Power System. This course aims to cover all the theoretical and practical aspects that will be helpful for students in terms of preparation of their semester exam, also GATE exam, and many more. Now, what is power system? To explain briefly, we live in the modern era of internet. We can have the access of everything almost in no time due to the availability of the internet. However, we feel very, intolerant, disturbed, sometimes impatient if we face a power cut for a very small duration of time. In terms of comfort level, we need uninterrupted supply. So, where from this power is coming? This power neither is God gifted nor it is naturally evolved. This power has to be generated in various power stations. Thereafter, that power needs to be transmitted over a long distance, and lastly, it's to be distributed amongst lots of consumers. So essentially, power system comprises of three sections: generation, transmission, distribution. So as it stands, power system contains a large network. Not only that, it's not only the structure of the power system. Out of that a large network, if we have the n number of parameters, we need to monitor those n number of parameters day and night. Let me give you some examples. If we see the demand side, our demand, power demand is always fluctuating. It goes high in summer, it goes low in the winter, or even for a daytime, it is varying over the time. Okay. So, in terms of demand side variation, we need to regulate our generation side, generation of power. So if there is an imbalance between demand and generation, then there may be an issue of instability. So the generation side, the power generation has to be regulated continuously. Another example can be stated that everyone has heard fault. What is fault? If fault comes in a power system, a large current should flow. So if that enormous amount of current is allowed to flow, then that will be very much fatal to costly electrical equipments like generator, motor, transformers, and many more. So we must intercept that high value of current quickly. So our defense system must be very strong, which can detect the fault, then intercept that fault and isolate that fault from the healthy section. So our defense technology or relaying technology should be very powerful so that we can take preventive measures. So fault current or the current at various buses needs to be regulated continuously. Okay. So these the two examples by you can understand that it's not only a huge network and they are steady state performances, but if you get n number of parameters out of that large networks, you need to have a closed loop on those n number of parameters. This course, power systems, will be discussed in several phases. In the first phase, mainly transmission and distribution of power will be discussed. Remaining topics will be coming later. So at last, I am reciprocating my best wishes to the students. I hope this course will be interesting and you will find it very helpful for your academic career. So, looking forward for your active participation. Thank you.